Alright, ladies and gentlemen, now that you've gone through an exploration activity dealing with graphing square root and cube root functions, we're going to take a closer look at how exactly we can go through graphing these equations. A lot of the information that we're going to talk about is based on what you've already discovered in the exploration activity. So, if there's something that's not making sense to you, please make sure that you ask right away. Now, the first equation that I want to graph is y equals 1/2 times the square root of x. So, based on what you found in your activity, the x values that I want to use for a square root function are 0, 1, 4, and 9. And I want to use those because I can take the square root of those values and I get really nice numbers. I don't have to deal with any decimals. Now that I have the square root of x, I want to multiply the square root of x by 1/2. So 0 times 1/2 is 0, 1 times 1/2 is 1/2, 2 times 1/2 is 1, and 3 times 1/2 is going to give me 1.5. Now, for each point that I want to graph, I know I want to plot y or x comma y, and I know in this case y is equal to 1/2 times the square root of x. So I'm basically going to graph this first row and this third row. So if I want to plot these, I'm going to plot 0, 0, 1 comma 1/2, 4 comma 1, and 9 comma 1.5. So this is going to look slightly different than the parent graph, but remember that the basic shape will stay the same. You already discovered what the parent graph looks like in the previous activity. Based on what we're looking at, if we want to identify our domain and range, remember that domain is our x values and ranges are y's. So in this case, x is going to be greater than or equal to 0, as are our y values. Y is also greater than or equal to 0. So let's go ahead and try that same concept with example 2. For example 2, I'm looking to graph y equals -2 times the square root of x. So my x values stay the same, and they always will. We're going to use these values when we're graphing a square root function, and we can go ahead and eliminate this last column. The square root of 0 is 1, or the square root of 0 is 0, 1, 2, and then 3. And now, instead of multiplying by 1/2, I want to multiply by -2. So I'm going to get 0, -2, -4, and -6. So I'm going to go ahead and plot those. I should have 0, 0, 1, -2, 4, -4, and 9, -6. As soon as I plot those, our graph should look like that. And we should recognize from our previous activity that this negative sign out in front is going to give us an x-axis reflection. So it's going to basically reflect it over the x-axis. Now that the graph is drawn, I can go ahead and find my domain and range. We should see that all of our x values are greater than or equal to 0, and all of our y values are going to be less than or equal to 0, because now we are looking underneath the x-axis to find the graph. Okay, so let's move on. Let's try another example with example 3 on the second page. For example 3, I'm looking at the function y equals the square root of x minus 3 plus 2. So I'm going to start off by doing the same process. I have 0, 1, 4, and 9. I can, of course, take the square root of those values. So I have 0, 1, 2, and 3. So I'm going to go ahead and plot those very lightly. You'll notice that we don't have any number out in front, so I don't have to multiply these values by anything a third time. Now, one thing that we should notice is since there's an x minus 3 on the inside, that should remind us that the graph is going to be moved right 3 units, and of course up 2. Now I could go about this a couple different ways. I could have you create a number of different graphs for each individual problem, or we can get creative. And I'm going to choose to get creative. So with each of the points that we see on our graph, I can take each one individually and move it right 3 units and up 2. So that's my first point. For the second one, right 3 units, up 2, right 3 units, up 2, and then right 3 units, up 2. And for me, for what I'm doing right now, my green graph is going to be my final equation, or my final graph of the function. Okay, now if I'm looking to find the domain, I'm still using x and y, but now I want to base it off of this green graph. So I'm going to see that x is going to be greater than or equal to 3, and my y values, I'm looking at y now, y is going to be greater than or equal to 2. Okay, so let's try the same thing. For example 4, we're really bringing everything together. I'm going to go ahead and switch pens back very quickly if I can. My x value 0, 1, 4, and 9. The square root 0, 1, 2, and 3. And now I'm going to multiply each of those values by 3. So I'm going to go ahead and plot those to get my basic shape. So we're taking into account the vertical stretch, and then I just have to move everything left, right, up, or down. If you're feeling comfortable with this, you can go ahead and try example 4 as we go through it. Okay, now for each of these, I have my basic points plotted, but based on the equation, I want to move everything left 1 unit and down 4. So I'm going to start with this first one at the origin. Left 1, down 1, 2, 3, 4. Left 1, down 4. Left 1, down 4. And then finally left 1, down 4. Okay, now once again, my graph, the function that I'm given, the function that I'm asked to graph is going to be the one in green. So the domain, if I'm looking at x, my domain is going to be greater than or equal to -1. And my range, my y values are going to be greater than or equal to -4. Okay, so we're getting close. We're about halfway there. So let's go ahead and take a look at cube root functions. Now, it's going to be the same process, but my values are going to be a little bit different. Anytime I'm graphing a cube root function, I want to use the values -8, -1, 0, 1, and 8, because I can find the cube root of those very easily. So if I take the cube root of each of those functions, I'm going to get -2, -1, 0, 1, and +2. Now in this particular problem, it's telling us that we have a vertical stretch of 3. So I'm of course going to multiply each of those by 3. And now I'm going to go ahead and graph. So I'm graphing -8, -6, -1, -3, 0, 0, 1, 3, and 8, +6. Now we should notice that our shape is going to be a little bit different, and I'm also going to see that my graph extends in both directions. So since it extends, I'm going to be able to say that both my domain and range are all real numbers. And I even have a symbol for that, and I can write all real numbers as this R with a double line, telling me that no matter which value I plug in, I can get some number back out. Okay, so let's go ahead and try example 6. Example 6 is going to be very similar. I'm going to go ahead and start filling in my table, which is what we should do each and every time. So -2, -1, 0, 1, and 2. And now I do want to multiply everything by -3/2. Okay, so when I do that, I should get +3, +1.5, 0, -1.5, and -3. Okay, so if I go ahead and plot those, 8, 3, -1, 1.5, 0, 0, and so on. And as soon as I get those finished, I should have a graph that looks like this. And now we should start seeing a pattern. We should see that this graph also is going to extend. So my domain and range are both all real numbers. Okay. Now, we're going to bring a couple things together as we start wrapping up. For example 7, I'm still dealing with a cubed root, but we should notice that I'm going to move left 4 units and up 3 units. So I'm going to start off just by plotting those basic points, and then I'll shift each one individually. So for my x values, -8, -1, 0, 1, and 8. -2, -1, 0, 1, and 2, which is what we get when we take the cube root of each of those x values. Now, if I go ahead and plot those, I don't want to do a lot, so I'm just going to keep them very basic. And I know that for each one that I just plotted, I want to move it left 4 units and then up 3. So I'm going to start all the way on the left. over 1, 2, 3, 4, up 3. Next one, over 1, 2, 3, 4, 1, 2, 3, 4, up 3, 1, 2, 3. Over 1, 2, 3, 4, up 3, over 4, up 3, and then finally over 1, 2, 3, 4, up 1, 2, 3. Okay, so if I go ahead and connect these, there's my graph. Okay, and we should notice again that anytime we have a cube root function, my domain and range will be all real numbers. So I would suggest filling in your table. If you have a vertical stretch or a vertical compression, make sure that you multiply by whatever number's out in front, and then plot each of those points and then just move them in whichever direction you need based on either your horizontal or your vertical translations. Okay, so for this last one, let's go ahead and just jump in before we finish up. Same x values, same cube root of x values, and now I'm going to multiply each of those values by 2. So I'm going to have -4, -2, 0, 2, and 4. So I can go ahead and start plotting. So -1, -2, 0, 0, 1, 2, and 8, 4. Okay, I have my basic graph or basic points plotted. Now, the only other thing that you'll see is that, for example, 8, each point is being moved down 1 unit. So down 1, 1, 1, 1, and 1. So there is my final graph. Okay, and if you haven't guessed by now, we should see our domain is our real numbers, our range is our real numbers, and we should be good to go. So we're going to go ahead and stop here. I'm going to take questions over 9 and 10 together in class, so I do highly recommend that you try example 9 and 10, see if you can figure them out, and if not, we'll know exactly where to start tomorrow. So please make sure that you get these copied down, make notes of any questions that you have, and come to class with them. We'll see you tomorrow. Bye.